had something from a record like
if light puts things together, then we could take them apart. And this is one way I did it. I put a little experiment together, and this is what I did. I drew a triangle on a table. Then I got 3 little tetrahedrons, which were coat hanger wire, and they stood one here like that. Here's your tetrahedron here. That's a bad show there, but there's one stood here and one stood here, and here's the point of them. They're looking at each other. Let's put on a plane. There's one standing here, and there's one standing here, and there's one standing here. Okay? Now, of these 3 tetrahedrons, they're only about 9 inches high, and they were only made of wire. But the shape that I was talking about has an influence on it. The shape of those tetrahedrons created a movement inside let's call it a pyramid. And the movement itself started to cooperate with the other 2. This one's talking to that one and that one. Now, I put a little wooden arm here. I'll draw it sideways. It's like a lamp post, a wooden arm, and this arm stuck out. And on the end of here, I hung a piece of string with a small piece of zinc, pure zinc, about 2 inches long, 1.5 inches wide, and 1/16 of an inch thick. And I hung it here, like that. It was over here, stood here, and it's hung down there. Here's your zinc. So between this pyramid here and this one here, they are talking to each other, if you like. That's in simple terms. What is happening is that they send electrons to each other. You probably heard about Tesla's energy through the ether. These do it naturally. Now, the energy that was being collected into here, I'll describe exactly how it happens in a minute. But these 3 pyramids are talking to each other. In other words, this one's sending energy to, it can't go to there, it goes to the nearest thing that attracts it. So the energy is shooting from here to there, and there to there, and there to there. Now, anybody will tell you that zinc is a pure metal. It's not made of 2 or 3 different items. It's just pure metal. Well, I beg to differ, because after about 3 weeks of this bombardment going on, these were sending out electrons towards each other and hitting the zinc. Now, zinc is held together in proton form. That's way beyond the electron. Now, if you hit zinc, or I'll deal with zinc, that's one I use. If an electron hits the zinc, electron can't come out. It wants in. The only thing it can kick out is a proton. So all these 3 were bombarding these electrons, and eventually, like it's kicking protons out, eventually the whole thing collapsed onto a little pile of powder here. A little pile of powder. And when I had that powder examined, it was a dirty calcium. Now, if you know the weights of your elements, you'll know that off the top of my head it's 65 point something, and I've got them here somewhere. There's about 25 moles per gram difference in the weights. 40 point something, I think. It's 40.8. I'm not sure. Doesn't matter. There was about 25 moles per gram. That's molecules per gram in weight, at atomic weight. So if you took the same amount of each, this would weigh one, that would weigh that, and one would weigh that, because this one here, your calcium, was found higher up that scale on the lighter side than the zinc. That was farther down here. It was heavier. Now, when I saw the difference that I had in weights, I tried to find something in the periodic tables that had that weight. But what had I removed? All I know was that my zinc had collapsed, and I had it tested, and it was calcium. I tried to find a number that would equal that, and not even a combination of different numbers would give me that answer. So I had to look for something else. And it was obvious to me really before I started, but I just wanted to be sure, that what I had removed was energy. I hadn't removed anything you can give a name to. I had removed energy. So I put this in a little tiny bag hung it on here, and I repeated the process. And believe it or not, after about 6 weeks, it's longer this time, it got smaller and smaller, and it changed colour too, and all I had when I tested it was aluminum. I'd come from zinc to calcium to aluminum. And there's a funny side of this, because a doctor will say that you don't have enough calcium in your system. I'll give you some calcium tablets. At the same time, somebody says, don't cook in aluminum pans, it's bad for you. But when you get calcium tablets, there's aluminum in it, isn't there? Energy-wise. Not only that, they say, okay, get out of the aluminum and get out of the calcium, I'll give you some zinc tablets. They gave you all three. Because in energy form, like I told you when we first started, we must regard everything in its electrical magnetic form. Or else you're not going to understand me. Reduce everything in your mind to the electrical and the magnetic. And I will give you numbers. You can work these out for yourself. If that's the weight of an electron, you can prove it if you've got a calculator there. I know for a fact that hydrogen is 770 electrons. That's hydrogen, 1 point something. So if you take this number here and divide it into any one of your elements on the periodic tables, you can find their electronic magnetic content. Now in a few minutes we're going to turn to something else that it's a continuation of this, but I'm going to take you inside a crystal. I suppose if you wanted to buy a house, you'd want to look through it. And so if you want to be able to use a crystal, would it not be sensible to have a look what it's like inside, and what we can do, we move around in it, and find what spots do what. Now I'm going to take you to this chart over here, chart E, and I've drawn it in the shape of a triangle, because the molecules of your quartz crystal are pyramid shape, right down to the tiniest little molecules of your crystal. They are pyramid shape. So now the one that I've just taken now, I've enlarged it, and I'm going to take you inside to see what it's like. Now just imagine yourself now looking around your new home. First of all, this pyramid here would be no different to your big crystal pyramid. It's a series of these put together in a big one. Now if you want to find the areas that are most useful to you, the functional areas, then there are certain things you have to do and abide by. First of all, I'll show you how to find the 3 magnitudes of a pyramid. When I say magnitudes, I mean if you in the house, the heat at the ground level, floor level, will be different to halfway up, and it'll be different again in the ceiling. We're not talking about heat, but energy rises and does practically the same thing. So now, what we're looking at is really this size of this base here. If it's squashed up into there, whatever's in here it has to get into a smaller place and become stronger. Now, to find the three magnitudes, or three divisions, never mind the intermediate bits in between, the three main ones. First of all, you measure the side of, if you could draw this on paper for yourselves, you draw the length of your pyramid, measure it, and you find the center mark here. And you do the same here and find the center mark. Then with a square, put it on the side here and draw a line in, compass if it's like, and one in there. And where they touch, that you draw a line across parallel with the base, and you have the basic energy up to the first dimension, or first magnitude. It is multiplied there by 10. Whatever you had in here, 150 gauss I suggest is here, 150 gauss at ground level. By the time it reaches here, it is 1500. And where by the time it goes farther up to the top, it comes 15,000. But now we only have one dimension yet, or one magnitude. The second magnitude is found by measuring from here to here, the center mark of it, halfway between the two, and draw a line across. Now you have dimension 1, dimension 2, or magnitude 1, magnitude 2. And each of these multiplies by 10, so that whatever magnitude you draw into the pyramid, naturally, let's talk about naturally, not force-fed, whatever ends you draw into the pyramid would come out of the top 1,000 times stronger.